Hey guys, welcome back. It's been a long time. So let's see today's GFG question, and then we can solve the uh, LeetCode's daily question. Okay. So this is today's question: node and the ancestors max difference. Okay. Mm, Given in the root of binary tree, find the maximum difference between an ancestor node A and its descendant node B. The maxima is AB. For example, here 5 to 1. This is root, and then maximum difference we get is 4, which is between 5 and 1. All right. Uh, so it's saying in terms of node. Okay. So here the maximum difference we can get -1, which is 1 and 2. Okay, and 3 and 7. Okay, so we need the maximum uh, difference between a node and ancestor. Okay, so how we can solve this problem? Okay, uh let let just think about it. Okay, so mm, how we can solve it? Okay, let's go to the notepad and then see what I can do. Let's say this is node A, and this node has a child, let's say B. So okay, okay, if we can figure out for every node, okay, the ancestors, let's say there's C also. So for C there are two ancestors, B and A. Okay, then we can check the maximum difference. Okay, for these two. Let's say for this is D. So again for D we have this two ancestors, right? Uh, so since we need max difference, okay, so for that child must need the lower value and the parent must need the higher value. Okay, this is what we get maximum difference, right? Because it's like uh, ancestors minus that node value. This is how we are calculating. Okay, so let's see about it. Okay, where is the question? So is it possible that we can figure out while traversing to tree? Let's check it. Okay, for exploring 2 we should pass the mm, this is binary tree, right? So how about uh going to, since we can get to leaves, right? Let's say this is ABCD E, F, and G. Okay, so when we reach the leaf node, and then it returns the number of it. Okay, let's say G returns we need a good example for this, right? So let's look at the existing one. Okay, uh let's choose this one first, and let's see what we can do. So let's say this returns 2 and also the maximum difference. So since it does not have any child, so it will return int min. Okay, and again similar, this will return 1 and int min. Okay, and now for this it will become an ancestor for this one and this one. Then choose the maximum difference. Okay, difference that we got uh, as of now, and then before considering this ancestor we can check the maximum difference, because we will be passing 3 parameters. One is let's say okay, so we need this child value as minimum as possible, right? So we will pass the minimum value we got so far. Then we will pass the maximum value, the maximum difference that we got so far. Okay, the maximum difference that we got so far. And yeah, these 2 parameters things like enough to figure out what is the maximum difference, I guess. So let me dry run just. Okay, so we will be having a node, our custom node, which has these 2 parameters: min value, which represents that minimum value that we got so far. Okay, and the maximum difference that we got so far. Okay, so this is what the node needs, our custom node. So we will do a simple traversal. Okay, so first we will start from root, then go left, uh, then go left. Since it's nothing, so it will return the minimum value, let's say int max. Okay, and the maximum difference, it will return int min. Okay, just assume like this. Okay, and this goes up, and then we compare this with the with this. But before comparing, we go to this direction, right? Then again it will return the same thing, the minimum value that we got so far. Again, there is one correction. When this is what 2 gets when 2 calls the left call, but since there is no left, then for 2 this returns, then 2 will modify it according to it, that the maximum difference stays still same, since there is integers mini value that we got so far is inf max. Okay, so 2 will modify it according to it. So 2 says that no, that minimum values what we so far is 2, and the maximum difference that we got so far is, again let's say 2, because if there is only one node, then What's the maximum difference? It's 2, I guess. uh let's just check if there is only one node. Okay, so it's showing at least you will have two nodes. Okay, uh then consider there will be no such thing that only one node exists. And if that's true, then we will modify minimum value according to 2, and then maximum difference that we got so far is still int min. Okay, int min. Then 2 returns this data to 5. 5 before checking it calls to write, then write again, sends that data which will be min value 1 that we got so far, max difference again it's infinity. Then now check the minimum that we got so far is 1, uh then check with the 5, 5 minus 1, what's the difference. If it's minimum, uh it's greater than the maximum difference that we got so far, this is minus infinity. Okay, and then according to it, it will return something like that. So this is what I'm thinking. This is just a raw coding session. Okay, if you are not comfortable with this, I'm sorry. Okay, so let's see what we can do. Class, uh let's say custom node, but let's say what should I call? mm, Info. Okay, and it will have minimum value that we got so far and maximum difference that we got so far, and this is constructor int minimum value and maximum difference. Min value is equal to min p, max difference is equal to max. Okay, now we will do node dot left. Okay, node dot right, it will return info left, info right. Okay, let's say ut. Okay, info node root. If root is null, in that case return new node integer dot min value, that max value, integer dot min value, this is the maximum difference. And if it's not null, then obviously we need left call and right call. Now according to it, check the minimum value among these. Math dot minimum of left dot min value, right dot min value. So once we got the min value, then calculate the current difference. That's current difference will be root dot data, root dot data minus min value that we got so far, and update the difference. Okay, and max difference will be math dot max whatever the difference we have got so far from left dot max difference, right dot max difference, and that max difference now update with the current one, or current difference. Okay, we updated the mean value and the max difference. Now we will return this data. Since we should update the mean value, that the current value could be the minimum value. Okay, so for that we should return, calculate the mean value. Once we calculated the current difference, math dot mean of mean value, or the root dot data. Okay, now return new node, the mean value and the max difference that we got so far. And this is how it looks. Now here we need just the node, and we'll pass the root into this, so it will check from the root every thing, and then once we have this, we will return node dot max difference. Just check. Okay, so it's info, right? Info. Okay, I'm sorry. So it's calculating 4, right? Again, check this one. Okay, it's calculating. Let's try to submit. Well, it's accepted. Okay. So we able to solve this. Okay, but for LeetCode, I need a break. Okay, I have to go. But let's see, just if it's easy, then we can do. But if it's medium or hard, then we will take a break. Okay, so it's looking easy. Distribute elements into 2 arrays. Okay, you are given a one indexed array of distinct numbers of length, and you need to distribute all the elements of nums between 2 arrays, array 1 and array 2, using n operations. In first operations, append the num1 to array 1. In second operation, append num2 in array 2. Afterwards, the ith operation. Afterward, in the ith operation, if the last element of array 1 is greater than the last element of array 2, then append the nums of I to array 1 because it's greater, and otherwise to array 2. The result is formed by concatenating the arrays 1 and 2. For example, the array 1 is 1 2 3 4, 1 2 3, and then the array 2 is 4 5 6, then the result will be 1 2 3 4 5 6. Okay, so these kind of questions, in my view, we need some toggling, I guess, because it's we don't actually need to create the array 1 and array 2. This is just my experience says, but let's see, if it needs, then we can create. Okay, The nums array is 2 and 3. After the first two operation, which one is this? Okay. Uh, nums1 to array1 and nums2 to array2. So let's say this array1 is this and array2 is this, and in which we pass nums1 to array किधर गया nums1 to array1. So nums1 is 1 to array1. Okay, it's one best, that's why it's array1 2 and array2 is 1. And then for ith, whatever the greatest among these, append it. So this is greatest, append it. And this is how it works. So since the all elements are distinct, so it says there is meaning, okay, distinct elements, and these are the hints that we should look into it, okay. uh but right now I'm not going to solve in optimized way. Let's say array1 as the problem suggests. We'll create list1 and then you're gonna again list2 and arr1 but add nums of 0 and arr of 2 add nums of 1. That's what it says. For int I is equal to 2, I is less than nums dot length plus plus I, and then since this is first problem, I guess tomorrow we will see the hard one, and tomorrow if I'm able to record, then we will optimize it, okay. But for now I don't think we should look into this matter. Yeah, so if arr of 1 dot get arr of 1 dot size minus 1 is greater than arr 2 dot get arr 2 dot size minus 1 if it's nums of I, otherwise nums of I, okay. And once we have this, then we need to concatenate, right? So int result new in since okay, we can modify the given one, but let's see, we can create a new one that is nums dot length, okay, or int. So okay, while eyes int eyes 0 to eyes less than that size arr1 dot size plus plus I need k, okay. Result of k plus plus will be arr1 dot get I, okay. Similar for array2, okay. Return result arr2 dot size. Let's try to submit. Okay, so obviously we can improve it, I guess, but we should find out we should need some sort of dry run to able to get this, uh, you know, the constraint are saying that we can solve this even better that we solve here. Okay. uh yeah, for now, I guess, yeah, this is the end of video. Thank you for watching.